Hey developers, welcome to Code to Clarity, Dynatrace versus OpenTelemetry. Today we're kicking off a deep dive into something absolutely critical for modern software development: observability. It's more than just logging. It's about truly understanding your systems. Think of it this way. When you're driving your car, you don't just rely on a check engine light, right? You want to know the engine temperature, oil pressure, RPMs, all that granular data displayed on a comprehensive dashboard that actually helps you diagnose problems before they become critical. That's the core idea of observability for your applications. It's about building that sophisticated, custom dashboard for your code. At its heart, observability for developers is the ability to understand the internal state of a system just by examining the data it outputs. It's not just if your application is working, but how it's working, why it's slow, or where it's breaking down. For us, that means having the right tools to debug complex distributed systems, optimize performance, and gain deep insights into application behaviors. You might be thinking, I already have logs, isn't that enough? And for simple, monolithic apps, maybe. But as systems grow, logs become a needle in a haystack. Modern observability stitches together three core data types: logs, metrics, and traces. Logs tell you what happened at a specific point. Metrics give you aggregated numbers, like CPU usage or request counts over time. And traces are the game changer. They show you the entire journey of a single request as it flows through multiple services, functions, and databases. I've seen teams spend days, even weeks, trying to chase down a bug that only appears under specific load conditions in production. Picture a moment where a customer complains about a slow transaction, but you can't reproduce it locally. Without proper observability, you're just guessing. A trace can pinpoint the exact microservice, database query, or even line of code that introduced latency, even across a dozen different services or cloud functions. This integrated view lets us move beyond reactive debugging, waiting for something to break, to proactive optimization. We can identify bottlenecks before they impact users, understand the precise impact of new features, and even predict potential issues by seeing trends in our data. It's about confidence in your code, knowing you can quickly diagnose and resolve anything that comes your way. It fundamentally changes how we interact with and maintain our applications in production. Now that we understand the what and why of observability, let's peel back another layer, because next, we'll dive into how this crucial data is actually collected. And that's where Dynatrace and OpenTelemetry take fundamentally different approaches, which we'll explore when we talk about agents versus SDKs and collectors. Okay, so we've established why observability matters for developers. Now let's dive into the core technical differences in how Dynatrace and OpenTelemetry actually collect that crucial data. We're talking about the architectural foundations here. Think of it like this. If observability is building a custom dashboard for your car's engine, Dynatrace is essentially a pre-built, all-encompassing smart system that the car manufacturer provides. You install a single component, what we call an agent, and it just does its thing. This agent runs alongside your application, whether it's on a server, in a container, or even serverless functions. Its superpower? Auto instrumentation. This means it often injects itself into your code, or even the runtime itself, without you having to change a single line. It automatically discovers services, dependencies, and starts pulling out metrics, traces, and logs. It's incredibly powerful for getting deep, immediate visibility right down to individual code methods. But it's also a highly proprietary system designed to feed data directly into the Dynatrace platform. Now let's flip the script to OpenTelemetry, which takes a fundamentally different and arguably more modular approach. If Dynatrace is the integrated car dashboard, OpenTelemetry is like wiring in standardized, open-source sensors and a separate central processing unit to get the exact data you need, no matter whose dashboard you eventually connect it to. At its core, OpenTelemetry offers language-specific SDKs, software development kits. These are libraries you integrate directly into your application code. They provide APIs for you to manually instrument your application, saying, hey, this is a new trace, log, or metric. While auto instrumentation exists for some languages, the real power often comes from explicit control. I've seen teams leverage these SDKs to precisely capture business-critical flows, even when dealing with legacy services that a black box agent might struggle with. The data collected then gets sent to an AGLIS, OpenTelemetry collector. This is a separate process, often running as a sidecar or a dedicated service. It receives, processes, and then exports that data, formatted in OTLP, or OpenTelemetry Protocol, to any compatible backend, whether that's Dynatrace, Grafana, or many others. This gives you immense flexibility and directly addresses concerns about vendor lock-in.
So, what are the core implications of these two vastly different architectures? With Dynatrace's agent, you get incredible convenience and speed to value. Installation is often simple, and you gain deep, out-of-the-box visibility with minimal configuration. It's like having that car dashboard perfectly pre-wired. However, this convenience comes with a trade-off. It's a proprietary system, meaning your data is primarily formatted for and sent to the Dynatrace platform. This can lead to what developers often refer to as vendor lock-in, where migrating your observability data or switching providers can be challenging. OpenTelemetry, on the other hand, prioritizes control and flexibility. You own the instrumentation, the data format, OTLP, and the data's destination via the collector. This means more upfront setup and configuration effort, as you're essentially wiring those custom sensors yourself. But the huge benefit is data portability and vendor agnosticism. You're not tied to a single platform, giving you freedom to choose or even swap out your backend analysis tools as your needs evolve, or as vendor strategies shift. You might be thinking, which one is right for my project? That depends heavily on your specific needs and long-term strategy for customization versus convenience. We'll explore exactly how these integrate with your code next. Now that we've grasped the architectural differences between Dynatrace's agents and OpenTelemetry's SDKs and collectors, let's zoom in on what this means for your actual code. First up, Dynatrace. Its primary approach for application monitoring is often described as automatic instrumentation. What this means is, once you deploy the Dynatrace OneAgent alongside your application, it intelligently discovers and instruments common frameworks and libraries for you, often without you having to touch a single line of your business logic. It's like having a mechanic who automatically installs a whole suite of performance sensors in your car, already wired up, and sending data to a pre-built, comprehensive dashboard. But what if you need to trace something super specific in your unique code? That's where Dynatrace's SDKs come in. For languages like Java, .NET, Node.js, and others, you can use these SDKs to manually add custom code to capture specific events, metrics, or logs that the automatic instrumentation might miss. It's about getting granular when the auto magic isn't quite enough. Then we have OpenTelemetry, which takes a more explicit, developer-driven approach. Instead of an agent trying to figure things out for you, OpenTelemetry provides a set of vendor-neutral APIs and SDKs that you embed directly into your code. This is where the car analogy truly resonates. You're choosing exactly which standardized sensors you want, like a speed sensor, a fuel gauge, or an oil pressure monitor, and then wiring them into your custom dashboard. You might be thinking, does this mean more work? And often, yes it does. You're explicitly calling functions in the OpenTelemetry SDK to create spans for traces, record metrics, or add attributes to logs. The benefit here is immense control. You decide what data gets captured, when, and with what context. It supports a vast array of languages, from Python and Go to Ruby and C++, giving you incredible flexibility to instrument nearly any part of your polyglot system. So what's the trade-off in your day-to-day coding? With Dynatrace, you often get a lot for free right out of the box, especially for well-known technologies. It's a quick win for basic visibility, requiring minimal code changes. The downside is that if you need to deeply customize how data is collected, or if you want to send it to a different backend, you're working within Dynatrace's ecosystem and APIs. OpenTelemetry, on the other hand, gives you maximum flexibility and portability. You write more explicit code, but that instrumentation isn't tied to any single vendor. It adheres to open standards, which means if you decide to change your observability backend later, say from one vendor to another, your application code doesn't need to be rewritten. It's observability-as-code, truly owned by you. This distinction is crucial for avoiding vendor lock-in, a pain point many of you have expressed concerns about. And understanding these differences is key because your choice impacts not just your monitoring, but your entire development workflow and future architecture. Next, we'll dive into some practical implementation examples to see what this looks like in action, starting with basic instrumentation for both approaches. Alright, so we've talked about the architecture and APIs. Now let's get practical. How do we actually start instrumenting our applications? You might be thinking,
This all sounds great, but where do I even begin adding code to get this data? At its core, instrumentation is about giving your application a voice, allowing it to tell you what it's doing, how well it's doing it, and when something goes wrong. Think of it like adding sensors to critical parts of your car's engine. We want to capture two main types of signals: traces and metrics. Traces help us follow a single request journey through multiple services, seeing every step it takes. Metrics, on the other hand, give us aggregated data, like the average response time for a specific API endpoint over time. It's the foundational step to understanding application behavior, making debugging less of a guessing game and more of a detective story with clues. So far, we've talked about what observability is and how to get those initial signals, those raw measurements, out of your code. But instrumentation is just the beginning of the journey for your data. Once you've added those sensors to your application, whether through Dynatrace's intelligent agents or OpenTelemetry's SDKs, you're generating what we call the KENI, 3 pillars of observability: metrics, traces, and logs. Metrics are your aggregate numbers. Think CPU usage, request counts, error rates, giving you a high-level view. Traces show the end-to-end path of a single request across multiple services, like breadcrumbs through a complex system. And logs are those detailed, time-stamped records of events within your application, giving you granular context. Each of these gives us a unique lens, a different kind of raw data, much like the various sensors on your car's engine providing distinct readouts. Now, this raw data doesn't just magically appear in a dashboard. It needs a way to be collected, processed, and then sent to a backend system for analysis. This is where agents and collectors come into play, acting as the critical intermediaries. For Dynatrace, this is handled largely by its OneAgent, a powerful single agent that automatically discovers your environment, injects instrumentation, and collects all 3 data types, often with minimal configuration. It's like a sophisticated, pre-wired diagnostic port for your car, consolidating all the essential engine data for immediate analysis. With OpenTelemetry, the data often flows through an OpenTelemetry collector. You might be wondering, why another component? Well, the collector is a vendor-agnostic proxy that can receive data in various formats, process it, maybe filter out sensitive information, enrich it with metadata, and then export it to various destinations. This gives you immense flexibility. Picture a moment where your microservice architecture is growing rapidly, and you need to ensure consistent data collection across disparate teams and technologies. An OTel collector becomes your unified gateway, standardizing the stream of information before it hits your chosen analysis tool. It's like building your own custom wiring harness, allowing you to connect any standardized sensor or gauge to your dashboard, processing the signals along the way. Once our data is collected and pre-processed by agents or collectors, it needs a home. It's time for the backend analysis tools to take over and turn this flood of data into actionable insights. For Dynatrace users, this is their proprietary platform, a comprehensive, all-in-one solution that automatically correlates metrics, traces, and logs, providing a unified view for root cause analysis right out of the box. It's the fully integrated, high-end car dashboard that interprets every signal and presents it beautifully, telling you exactly what's wrong and where. For OpenTelemetry, the destination is typically a suite of specialized, OpenTelemetry-compatible backend systems. You might send metrics to Prometheus, traces to Jaeger, and logs to Loki or Elasticstack. The beauty here is choice and flexibility. You pick the best tool for each job, often leveraging open source or existing investments. This setup requires more upfront integration work, like connecting your standardized gauges to separate displays for oil pressure, RPMs, and fuel levels. But it grants you granular control and avoids vendor lock-in. Understanding how this data flows and where it eventually lands is crucial, because the architecture you choose deeply impacts performance. So what exactly is the overhead of all this instrumentation, and how can we minimize its impact on our running applications? When we talk about instrumenting our applications for observability, there's an elephant in the room that every developer eventually faces: performance overhead. It's the cost of gaining clarity. Much like installing those extra sensors and gauges in your car's engine, while they give you vital data, they do consume a tiny bit of power themselves. Collecting metrics, traces, and logs isn't a free operation. It consumes CPU cycles, memory, and network bandwidth. The goal isn't to eliminate this overhead entirely. That's impossible. But to understand it,
quantify it, and manage it effectively. We want the insights without causing new bottlenecks.
You might be thinking, so, how do Dynatrace and OpenTelemetry compare in this regard? Which one hits my application harder? Well, the answer, as often in engineering, is nuanced. Alright, we've talked about performance overhead. Now, let's zoom out a bit and tackle perhaps the most impactful difference for developers. The technical flexibility, customization, and long-term strategic implications of choosing between a proprietary system like Dynatrace versus an open standard like OpenTelemetry. This isn't just about what data you get today, but what control you have over your observability future. Think back to our car dashboard analogy. With Dynatrace, you're getting that beautifully integrated, pre-built, high-performance dashboard. It has all the gauges wired in, all the sensors neatly packaged. It just works, right? But what if you want a custom gauge that measures something super specific to your experimental engine mod, something the factory never anticipated? With OpenTelemetry, it's like having a standardized wiring harness and a massive catalog of open-source sensors and gauges. You can pick and choose, wire them in exactly how you need, and even design your own. The core difference here is built-in convenience versus ultimate architectural freedom. You might be thinking, but can't Dynatrace be customized too? Absolutely. Dynatrace offers extensive APIs and SDKs that allow you to push custom metrics, add custom attributes to traces, and even extend its out-of-the-box capabilities. However, these customizations usually happen within its ecosystem and APIs. OpenTelemetry, by design, is about the freedom to instrument your code once and send that data to any compatible backend. This means your instrumentation isn't tied to a specific vendor's API calls or data format. I've seen teams struggle for true, unified root cause analysis because different parts of their stack were instrumented with disparate, vendor-specific agents. OTel seeks to solve that by providing a common language for all your observability signals. This open standard approach significantly mitigates the risk of vendor lock-in, a major pain point for many organizations. It allows you to swap out your backend analysis tool, say from one vendor to another, or even to an open-source stack like Grafana and Prometheus, without having to rewrite all your application instrumentation. It separates the how you collect from the where you analyze. With Dynatrace, while robust, migrating away means a significant effort to re-instrument your applications. Understanding this fundamental architectural difference is key to making a strategic long-term decisions. Next, we'll condense all this into a practical decision matrix, helping you decide when to choose which approach for your specific projects. Alright developers, we've explored the deep technical nuances of Dynatrace and OpenTelemetry. Now, let's bring it home. When do you pick what? Think back to our central analogy of building a custom dashboard for your car's engine. Dynatrace, in this scenario, is like choosing a high-end, pre-built, all-encompassing system from the factory. It comes fully integrated, beautifully designed, and ready to go, meticulously wired for optimal performance. This is your go-to when you need a unified, end-to-end view across complex, distributed systems with minimal manual effort. If rapid deployment, automatic AI-driven root cause analysis, and a truly integrated view from user experience down to code execution are your priorities, Dynatrace's powerful agents automatically collect and correlate metrics, traces, and logs. It's about getting answers fast, especially in critical enterprise environments, where minimizing operational overhead is key. It's the set it and forget it option for comprehensive insights, offering premium capabilities. Now what about OpenTelemetry? If Dynatrace is the factory dashboard, OpenTelemetry is like wiring in standardized open-source sensors and gauges yourself, giving you the exact data points you need, precisely where you need them. You might be thinking, but won't that take more effort? And yes, it often requires more initial setup and custom code using language-specific SDKs to instrument your application directly. But here's the powerful trade-off. Vendor neutrality. You own your telemetry data format and can send it to virtually any backend, Dynatrace included, or Grafana, Prometheus, Jaeger. This flexibility is invaluable if vendor lock-in is a significant concern, or if you need extremely fine-grained control over what data is collected and how. I've seen teams leverage OpenTelemetry to instrument legacy systems that proprietary agents struggled with, or to collect highly specific business metrics, ensuring they only process the exact data relevant to their custom use cases, which can lead to significant cost optimization.
But what if you want the best of both worlds? This is where a hybrid strategy truly shines, offering a flexible path forward that many developers find compelling. You can use OpenTelemetry for your application instrumentation, enjoying vendor neutrality and granular control, while still leveraging Dynatrace's powerful backend for analysis, AI-driven insights, and integrated workflows. Think of it as using your custom, open-source gauges for data collection, but feeding all that data into Dynatrace's sophisticated central computer for intelligent interpretation and display. This approach allows you to standardize instrumentation across different services and teams with OTel, while still benefiting from Dynatrace's advanced features like topology mapping, precise root cause analysis, and unified dashboards. It's an excellent option for organizations with existing OpenTelemetry investments or those looking for a phased adoption, ensuring future flexibility without sacrificing immediate deep insights. So, as you build your next application, consider: do you need the factory-built, unified power of Dynatrace, the custom open-source control of OpenTelemetry, or a smart hybrid approach? The choice depends on your project's specific needs, your team's expertise, and your long-term strategic goals for observability. Thank you for joining me on this deep dive into code to clarity. If this discussion helped you navigate modern application monitoring, please hit that like button, drop a comment below with your biggest takeaway or your current observability challenge. I read every single one, and for more expert insights and playbooks, subscribe to the channel and ring that notification bell. You can also find the full playbook and all resources mentioned in the description below. Happy coding!